or 112. In fact, quite frankly, our statistics show that the frequency of 100-degree temperature readings in our state has declined. It's become a rarer phenomenon for us. But with these high dew points, we still get these high heat index values. And they have consequence. They have biological consequence because, quite frankly, some organisms love tropical-like air masses, and they thrive. They thrive in those environments. We find volatility of some compounds we use in the agricultural landscape changes with these. We find our inland lakes, many of our lakes that we're so proud of, have been put on the impaired waters list in recent years because they can't give up their heat. When they warm from those long summer days, warms the water of those lakes, they can't surrender it at night because the overlying air is so laden with water vapor. And water vapor, after all, is the ultimate greenhouse gas. So it's not going to let that long wave energy escape. And so they build up and build up. We get a lot of water temperatures way up there, and of course makes them more hospitable for algal blooms and other things if they have the right nutrients. It's increased the workload for our healthcare industry because, quite frankly, in fact, the Mayo Clinic has a whole publication about this. I don't know if any of you in the room suffer from chronic obstructive pulmonary disorder or MS. Maybe you have relatives that do. But Mayo Clinic studies show that at a heat index of 91, doesn't need to even get to 100, at a heat index of 91, these people begin to suffer stress. So we have this differential effect going on with these high dew point conditions. We've had livestock losses in 1995, 1999, 2001, and 2006. We had quite significant and measurable livestock losses in the state due to heat stress brought on by the high dew points. And then lastly, we've sort of become much more of an air-conditioned state, even for those of us that like to escape to the northern climates and get out of the July heat. You go up there now and you find that the resort's got air conditioning for you, just in case the dew point gets up to 80. In fact, I was up at Voyageurs National Park 2 years ago in early August for a little vacation, and the dew point did reach 80, and the heat index that day reached 112. And that's right on the Canadian border, something that formerly was pretty much unheard of. The third attribute I alluded to was the precipitation and how it's becoming more variable, and it is increasing in quantity, at least at most places. This is a similar graphic to what I showed you for the state database for temperature. This is all observations. By the way, we're blessed to live in a culture that is so loaded with volunteerism, aren't we? I'm sure most of you greatly appreciate this. You've probably been helped by a volunteer more than once in your life. And our volunteer weather observers now number over 1,500, which is really terrific. It's terrific we have that number of observations to rely on. But their observations show the frequency of years that have been above the 75th percentile in recent decades has certainly been highly populated. And in 2010 was the first year in state history that, based on all observations in the state, we averaged over 34 inches of precipitation among 1,500 weather observers. That's how wet that year was. We also see a seasonality character to that. Here's the seasonal character. We've seen winters that have been kind of mixed, dry and wet, springs that have dominantly been wet, falls that have dominantly been wet, summers that more recently have been dry, previously in a very wet cycle. The background for that is that geography has waxed and waned. Here's a depiction of how the geography of, say, 29 inches or greater has waxed and waned over the history. 29 inches or greater on an annual basis is depicted here in the light and dark blue. And this is a snapshot of the state's averages for the period 1891 to 1920. So you can see the wetter portions of the state are confined to these areas. By the time we get to the Dust Bowl era, 1921 to 1950, this had shrunk to the 7 southeasternmost counties in the state. Then by the time we get to later in the 20th century, it had begun to expand again. And then by the most recent normals period, 1981 to 2010, you can see that fully half the state has an average precipitation of 29 inches or greater now. And so some of the background normals have changed. This is what Minneapolis-St. Paul has looked like since the mid-20th century. So they're up 20%. Let's see if we've got a couple of others. Austin, Minnesota is up 12%. Waseca, Minnesota is up 30%. Wilmer is up 28%. You can see there's variation. One mistake we make in terms of conveying the importance of precipitation to the public is we often dwell way too much on quantity. Quantity is but one attribute of precipitation that relates to consequence, but there's other attributes that are important. How much in our climate is liquid versus how much is frozen? And we have some statistical evidence that in some parts of the state now, even in winter, we're getting a higher fraction of our precipitation as liquid precipitation instead of frozen precipitation. Intensity, how much do we get in what period of time? Frequency, how frequent do we get it? We have great variation in that. Duration, seasonality, landscape relationship, a number of other attributes of the moisture of our environment are important because they have consequence. So I don't want to just talk about quantity. One change in the character of our precipitation, widely noted by the National Weather Service and the National Oceanic and Atmospheric Administration, is that the fraction of our annual precipitation that comes from thunderstorms is getting to be a bigger fraction. It's getting to represent a larger fraction of what we get on an annual basis. Notably, the whole Western Great Lakes region falls into this category. The IPCC goes a step further and they examine the entire world geography with respect to this characteristic. And they note that all of the places on the world map with the blue plus sign, including us here in the Western Great Lakes, are all experiencing the same character change. That is, a higher and higher fraction of our total annual precipitation is coming from thunderstorms. And of course, this is problematic because of the nature of thunderstorms. Thunderstorms are all about who gets it and who doesn't. And sometimes who gets it and who doesn't are right next to each other on the landscape. And so if you get a pattern of thunderstorm trajectories across your region that is static or constant, and you have 3, 4, 5 episodes like this, the disparity between who got it and who didn't gets to be a huge number. It gets to be a huge number. The other problematic aspect of the thunderstorm character of precipitation, of course, is you get too much too fast, and the landscape can't handle it. So what we see occurring in our state climate database is that the recurrence interval for given levels of thunderstorm precipitation is changing. We're getting increased frequencies in some categories, like the 2-inch rain, the 4-inch rain, the 6-inch rain, God forbid the 10-inch rain, etc. And that's what's happening. In southeastern Minnesota, anybody here from southeastern Minnesota counties? Where are you from?
Steele.
Steele, oh yeah, sure. Southeastern Minnesota has experienced 3 1,000-year flash floods since 2004. So I guess you could say they're not due for one for a while. That's the 10-inch, the 13, the 15, the 17-inch rainfall. All have been highly destructive, highly consequential. We've had episodes in our history of drought, you know, those places on the landscape that get missed. If we use the drought categories and we go back in time, We can document that drought occurred with consequence in all these years. But you'll note we're experiencing some frequency of drought on the Minnesota landscape. Not to say that the same area is getting drought all the time. It's moving around, but somebody's getting missed most years. Most years, someplace in our state is getting missed. And in 2012 was what we call a statistical singularity. Those of you that work with statistics know what I mean. It's a singularity is a population of one. It's such a unique sample, you call it a population of one. In 2012, we had 55 Minnesota counties, color-coded here on the map, declared by USDA to be in drought disaster. So they were eligible for federal drought assistance from the government. And at the same moment in time, we had 11 counties designated by FEMA as being in federal flood disaster and eligible for federal assistance for flood and flood recovery. And some of these were the same counties. So we had federally declared polar opposite weather disasters at the same point on the landscape, in the same county. This had never happened in our state history. Never happened in our state history. In the middle of all that drought, we had two new gauge flow record readings. The second week of June in 2012, we had a flash flood on the Cannon River in southeastern Minnesota that sent a volume of flow down the Cannon River that was higher than any previously measured flow. And the very next week, up in Duluth and Carleton County, Cloquet and Duluth and Two Harbors, we had another flash flood with up to 10 inches of rain that sent a volume of flow down the St. Louis River that obliterated all previous maximum flow volume on the St. Louis River. What happened in that episode was rather striking. Let's see if I've got it here. Yes. Here's a hydrograph for the St. Louis River. Now the St. Louis River up in Carleton County, we have measurements back to 1908. So we have 105 years of record of flow volume on the St. Louis River. Okay, so that's a context. That's a historical context. In June of 2012, following that mammoth thunderstorm rain up in that neck of the woods, the peak discharge volume measured on the St. Louis River went to 45,000 cubic feet per second. It obliterated all previous records for highest volume ever measured. And by the way, just for analogy, 45,000 cubic feet per second is the upper Mississippi at flood stage. But this is the St. Louis River. This is the Mississippi. Okay? And then we went back into drought. Remember 2012, we went back into drought for the remainder of the year. So 5 months later, by early November of 2012, we had a flow volume measurement on the St. Louis River of 458 cubic feet per second. So within 5 months of each other, we had 45,000 cubic feet per second, 458 cubic feet per second. In a 105-year record of volume flow on the St. Louis River watershed, the all-time extreme values are within 5 months of each other. This is symptomatic of the amplified variability that climate change is bringing to our state. How in the world do we adjust for this amplified variability? That's the challenge, watershed by watershed in our state. We do have the new NOAA Atlas 14 out. Thankfully, this came out this last year, and you can put a cursor. If you use it online, you can put a cursor. It's GPS based. You can put a cursor at any point on the Minnesota landscape, and you can get a derived graphical depiction of the distribution of the 5-minute maximum rain, the 1 hour maximum rain, the 1 day maximum rain, what have you, for that location. Or if you want to completely bury yourself in data, you can ask for the tabular output, and you can look at that. But for any location in the state of Minnesota, what do we want to deploy if we want to be active in climate adaptation for this change in the quantity and character of our precipitation? We want to deploy the best data set we've got, and this is it. This is why it's important to acknowledge this. It's now out there as a tool to be used. So there's been consequence of this precipitation change. We've had to give more attention to runoff sediment, shoreline management. Storm sewer runoff systems have been retrofitted for higher capacity. They want to accommodate the 8-inch rain or 10-inch rain. Modified fisheries in some cases, mitigation of erosion, flooding mitigation. Tremendous work by the Minnesota Association of Floodplain Managers in this state. All of this under most people's radar, but we have people working in climate adaptation almost continuously. I'm going to skip this. It's in my book. If you want to read about the Granddaddy Flash Flood in Minnesota, you can read about the Wright Flood. I just want to highlight one more point here. The people that study, I'm a Minnesotan, so I like to study what's going on in our own backyard. That's where I've spent most of my life. But others like to study bigger scales of things. In the Lawrence Livermore lab out in California, they studied the height of the troposphere, the Earth's lowest layer of atmosphere where all the action is, where all the heat and moisture and the cloud systems and everything else exists. And what they're finding is that across time, as planet Earth warms, the height of the troposphere is getting greater. The mixing depth, where all the action is getting greater. Especially so in the mid to high latitude positions. It's not changing all that much at the equator, but as the planet warms, it is changing in the mid to high latitudes. It's important to know this because this has potential consequence. As the mixing depth gets greater, convection, the mechanism that mixes the atmosphere on those long, sunny summer days with the Earth's surface heating and the warm air rising and carrying with it the water vapor, the mixing depth for convection to occur is increasing. It's getting to be a greater volume. What did we see over Minnesota? Whoops, can I go back there? What did we see over Minnesota in 2010? 113 tornadoes. First time in our country's history, Minnesota led the nation in tornadoes. 113. 48 on one day, June 17th that year. A wonderful day to be working for the Weather Service. I don't think you would have had time to go to the bathroom. But putting out 48 tornado warnings in one day. But what about Environment Canada? What about our neighbors to the north? June 22nd, 2007. The first ever EF5 tornado detected in Canada, in the provinces of Canada. Tremendous level of convective energy that's required to produce an EF5 tornado, but it was sufficient on that day in June 2007 to produce the first EF5 tornado in Canada. Or what about our polar bear friends up at Churchill on Hudson Bay? Tundra area, okay, tundra, 59 degrees north latitude. So you get stratiform clouds over Hudson Bay. You get low layer clouds. You don't get vertical cloud development. Yet the pilots for the aircraft that fly the polar routes, that fly over Hudson Bay down and land in Minnesota, were reporting cloud tops over 40,000 feet, and it produced in August of 2010 a thunderstorm rainfall of over 4 inches. Completely shattering all previous records for the maximum thunderstorm rainfall at 59 degrees north latitude. So if you don't think that having a deeper troposphere to have convection occur has consequence to it, rethink that, because it does. And so that's leading us to amplified surface water flow volumes, lows and highs in our state. I mentioned that characteristic. Increased frequency of drought somewhere on the Minnesota landscape. Impacts in the frequency and magnitude of insured losses. Increased frequency of heat advisories because of the high dew points. And really more public attention all the way from local units of government to